Hello and welcome to another session of my Data Preparation for Data Science webinar. My name is Gerhard and I'm a book author and data scientist at SAS. Today we are going to focus on data quality for analytics, and I will show you how you can quantify the effect of missing values on model accuracy in your supervised machine learning models. In order to quantify the effect of missing values on your supervised machine learning models, I have run many simulation studies. For these simulation studies, I have used real-life data from different industries, and all these simulation studies dealt with a binary target variable as a supervised machine learning problem. In order to start these simulations, I have made sure that the data that I'm using for the models are perfect in the sense that there are no missing values at all. So I ran the following procedure: that I dropped all variables with more than 5% of missing values, and for those with less than 5% of missing values, I dropped the observations. So this made sure that everything I have left is a complete and fully available data set for my models. Next, I run multiple modeling cycles to retrieve a very good and stable model with good predictive power. This model has then been used to define the list of input variables, which were frozen for all the simulation case studies. Before we take a look at the outcome of my simulation results, let's have a quick view on how my simulation setup looks like. The data that I prepared earlier are now split into training, validation, and test data. And as these simulations have been run a couple of years ago, at that time I still used SAS Enterprise Miner for the simulations. Today I would use SAS Model Studio. Next, I'm going to prepare my data for the scenario-specific settings. For example, to insert some random or some systematic missing values, and in return impute them also automatically. After this, I take the data and train my models in order to see how good the outcome and how good the results are. This procedure is not only run once, but with a couple of hundred simulations in order to make sure that I receive some stable results to quantify the effect of my simulation scenarios. For the missing value scenarios, which we're going to take a look here, I performed the following setup. I started with my data, and for a specific proportion of data, for example, for 10% of the observations, or for 20 or for 30%, I set the input variables to missing. I did this either with a random selection, but also with a systematic selection. Next, I used automatic imputation in SAS Enterprise Miner to impute these missing values, and finally use a machine learning model to train it to predict the outcome. This procedure has been run twice, one time just by not touching the scoring data, which will be finally used for the evaluation, and another time where I also insert the missing values into the scoring data in order to be able to evaluate these two scenarios. And finally, the model quality was assessed. Let's now have a look how the outcome looks like, and I have loaded the results of my simulation studies into SAS Visual Analytics, and we will see what we can learn from these simulation studies. In this bar chart, we see the different simulation types that I have run for my simulation studies. Here in this case study, we will take a look only on the blue scenarios, the missing random values and the missing systematic values. In other webinars, we will also have a look on the effect of a larger or smaller number of event of observations on the case studies, or what happens if you bias your input or your target variables. So let's take a look. What are the outcomes of missing random values and of systematic missing values on our scenarios? I've displayed the different scenario results here in a box plot, for example. So you see my different scenarios that I can select here in the header line, and I have selected here the missing random scenarios, meaning these are the scenarios where I inserted random missing values into my data. If we take a look here on the horizontal axis, we see the left one is the baseline, meaning nothing's got changed. So this would be, can be interpreted like the reference category. What would be the optimal model based on the data? The further we move to the right, the more random or systematic missing values I inserted into my training data. So you see 10%, 20%, 30%, and so on until 90%. And on the y-axis, we can see the correct response percentage of our model. So we see the more missing values we insert into our data, how does this have an effect on the response rate of our model. We also mentioned earlier that we want to differentiate between if this only is applied on training data or if this is also applied on the scoring data. For example, if we only applied on the training data, this would mirror a scenario, what happens if you have problems with your training data, for example in credit scoring, that your historic data has some problems with some missing values. However, in future, when you're going to apply the model, as this is for example used in application scoring, you won't have these problems because you can make sure in future that you capture all the necessary data. So this would be this scenario. The other scenario would mirror the effect that data quality problems might happen in the training, but also later on when the model is being applied on fresh data. Let's have a look now how this scenario looks like. We see that for randomly inserted missing values in the training data only, we see almost a very flat line in the box plots. There is a small effect how the model quality goes down the more missing values we have. However, we also see as they are inserted randomly and there is no systematic pattern attached to it, the model quality almost does not go down. This might look surprising in the first run because we might expect a shorter decline, a steeper decline of the model quality with more missing values. And I have to admit, when I first saw the results, I thought something was going wrong with my simulation. However, if you think this a little bit more in detail, you will understand that we are training the model here in a way saying it should be able to deal also with not perfect data. So this makes the model a little bit stronger, for example, like also with a denoising autoencoder, where you by purpose put some noise into your input data to have it to have a better fit out of your model. The same thing happens here. So if you are sure that your missing values are only randomly and they only appear in the training data, this does put only very little bias on your model outcome. The situation, however, is different if these missing values also occur in the scoring data. So if the model which you are going to apply to make decisions also contain missing values, we see that our model quality goes down to a certain extent. Let's flip again back to the training data. It looks like this. Scoring data, it looks like this. I would now like to switch over to a line chart because it makes a little bit better visible what's the difference between the various scenarios. I just wanted to make sure that I document that all the scenarios have also been observed by looking at the distribution and not only at the average. Okay, so let's again have a look. This is the same scenario as before. We see just missing values only in the training data, quite a flat line. Missing values also in the training, the scoring data, quite a steep line. So one of the learnings of this is very often we spend a lot of time in discussing whether 20% of missing values is bad or 30% is even worse or 40%. But we also see here we need to make sure in order to quantify this precisely for the outcome on our model quality, we should also investigate the business process. Do the missing values occur just in our training data or also in the scoring data? Let's now also have a look on how does this look like if we have systematic data. Or more precisely, what happens if we have systematic missing values in our data? Here I have not inserted the missing values randomly, but based on certain structures and clusters. And we see, even if this only occurs in the training data, we already have quite a descent in our outcome. So the more missing values we have, the less precise the prediction is. If this is now also happens on the scoring data, we see we have quite a steep descent. So again, if we compare this now, how does this look like for systematic and how does this look like for random missing values, we see again that the focus in your discussions when preparing data and discussing the effect of missing values, of course we should have some focus on do we have 30 or 40% of missing values, but also it's very important to investigate what is the structure of the missing value. Is it randomly or is it systematically? Finally, I've summarized the results here in a combined line chart. You see the red and the orange line for the random missing value scenarios and the dark and light green line for the systematic missing value scenarios. So you can see very easily that the biggest source of forecast quality decrease lies in the fact whether your missing values are systematically or whether they are also available in your scoring data. So in future, make sure that in your discussions you not only take a look on what is the percentage of missing value, but also what is the source and what is the background of my missing values. In order to quantify the effect of different types of missing values, I've used SAS Analytics to run a simple linear regression here. As the target variable or as the y variable, I have used % of response. What is the quality of the model that we built? As a continuous effect, I've used the percentage of missing values ranging from 0 to 90%, and I've included two categorical variables. What is the simulation type, meaning is it a random or a systematic missing value, and does it happen in the scoring data as well or only in the training data? If we take a look at the results at the parameter estimates of this model, we see the following. We see for the comparison between random and systematic values that on average in my scenarios, I had a difference of 3.6% of better model outcome if the missing values only occur randomly and not systematically. And I had a difference of 4.2% in hit rate if the missing values only occur in the training data when we build the model and do not occur when we also apply the model. And we also see that for each additional missing value, we see that we have something like a decrease of 0.1 per missing value % of our response rate. In my data quality for analytics book, I've also documented the simulation outcomes, and I've also built a simple scenario for a business case. In order to show you here some examples is that I'm having a scenario where I have 100,000 customers as a target group in every campaign, and on average I have a profit of $25 for each customer if he responds. So based on the models that we've built with a 19% of hit rate, we will end up on average with a campaign outcome of $475,000. Let's now take a look what happens if we consider the results that we just found here in the scenarios. If we now consider a scenario where we reduce the missing values from 50 to 30%, we see that we get an additional profit of this missing value reduction of 47,500. So we see that we can quantify the effect of better data quality based on the simulation scenarios and have a more educated decision on whether we should invest more effort in data quality preparations or just move forward with this model as we have it. Let's finally have a look on the findings of our missing value scenarios that we have seen here. First, of course, more missing values have an effect on model quality. It goes down the more missing values you have. However, we have also seen that it's very important to differentiate between the types of missing values. For example, random missing values just in the training data only have limited effect. If they only occur in the scoring data, the effect gets larger. And even stronger is the effect if they are not randomly but systematically, then we see quite a dramatic decrease in model quality. So always check the type of your missing values and discuss it with business or those who understand the nature of the data and how missing values might come into our training data. The takeaway is, don't in your meetings not only discuss the acceptable percentage of missing values, but go and discuss the why that happened, how did they come from. In another webinar in this series, I've also told you the story of my old Aunt Suzanne. And if you compare this story now with the systematic missing values, you see how important it is to understand the business process, how your data has been collected, and whether your missing values are randomly or systematically. You find a link to this webinar in the playlist here on YouTube, and I encourage you to watch it. In this webinar today, we have taken a look on a data quality for analytics topic. In my series in general, I speak on data preparation for data science, where I also speak how you can generate relevant features for your modeling process or how you optimally assemble the data to build good models. The entire webinar series is in the focus of the relationship of data preparation, data quality, and the application of data science methods for business reasons, and this is also in the focus of my books that are published with SAS Press. If you want to read more about such content, I regularly publish on Medium and LinkedIn. I do webinars on YouTube. You can find tips and tricks on SAS communities and can also download my programs on GitHub. Thanks a lot for watching. It has been a pleasure to talk to you.